let's continue on with those primitive data types on a complex number, which is still technically a primitive data type, if you think about it. But of course, it is also, at the same time, it's compound, right? Because you have two parts. You have a real imaginary part. On not many languages implement this, right? Python actually turns out it supports it, right? Of course, Python is using J, not I, right? Because I guess I was sort of using for iterators, and so they did not use I. So this format again, so 5 plus 2 squared, right? Maybe only it's a little bit bigger, right? So that's 5 plus 2 square roots of -1, right? So what's when you square it, it should be 29. No, Coppelt says 29, but I think it's 21. Let's take a look actually. If you do the math, right, it's 21 actually, right? Should be, answer should be. Okay, so the new model now is better, does better compound. So again, useful, nice to have. Technically, right? Many languages don't skip it because then you have to have a library to do this, right? So it's, you know, so a plus a squared, right? So it's, what's the 25, right? And then you have the two square roots of -1. If you square them, you get -4, right? Right. Just think about it, right? So 2.9, right? Let's see if we can do this. It should be -4, right? It is -4 plus 0j. So that's a complex number, right? So of course we can cast these two regular integers as well, right? So character type, most languages do have it, right? Python does not have it, right? Again, some issues is again whether it's primitive or not primitive. Again, if you're going to do UTF-8, it is not going to be a primitive data type. Right, so string data types, again, already technically not a primitive data type anymore, right? Because it's a sequence of characters, right? And of course, underneath you have some issues already with strings. For example, right, string length, of course, is a sequence. So one thing is length of the string, right? What's the issue with length of the string? Well, if you have a regular, you know, like modern language do a string, they have a length, right, built in. You have a sort of counter, right? However, classical C-type strings, what they use? How does a classical C-type string looks like? What does it look like? What is it? Do you know?
It was characters and there was
no terminator. There's a terminator,
yeah,
right?
Yeah.
So the issue is string length is actually costs how much time?
Oh, to the end?
Yeah, or to the end, because you have to count all the characters. So this is the issue. Sometimes people are, you know, using C, if it's underneath, they're calling string length on a classical C-type string, you get ON, and you have a loop, you get quadratic, right? By, you know, if you're doing something string, but something like string length, actually have a really long strings, actually might be a very dangerous, very hard, you know, linear operation, which you, of course, usually you want to pay this, you know, as you make strings, of course, you pay it, you sort of cache this information, usually, right? It's kind of useful to have the length of the string, right? So, right, so careful with that. So where is going to say, so, right. Yeah, I mentioned this, right? Yeah. And when careful, of course, also one thing is careful warning on string length. Yeah, and that's also right. That's one thing, right? Also string length in C. Yeah, right. Takes linear or very inefficient if you are going to loop. Yeah. So, right. Okay. So state. All right. So squares. Yeah, I mentioned this, of course. So enumeration types, right? Those already, of course, are sort of like your own, right? You already made enums, right? Very good data type to have. Why? Because you can specify your problem, right? You can specify what types are appropriate. Monday, Tuesday, Wednesday. What dates, what's available, basically. So you don't go out of the bounds. In fact, there's some languages which have like what's the name? Ada, I believe, is like very very strict even on regular integer types, right? So. Right, so native enumeration, if your language offers it, right, it's very good, so to say, your own a way of imprisoning your own, your program, which is good. You want to limit, right? You want to limit the kind of data you can use, right? So there's some design issues here, right? Let me this. So what's this here? Oh, there it is. Let me check this, fix this. So yeah, and also a couple issues here are when you're making enums, right? Is enum available in different definitions, like Monday or maybe color definition? Maybe you have different enums, right? Also, typically, right, enum values underneath they resolve to integers, right? 1, 0, and you can use some tricks, right? So sometimes those tricks are useful, but also sometimes they lead to some unnecessary, issues, basically, right? Yeah. And of course, then we get to arrays, right? And let me see the data types deeper, right? I want to go, right? Okay, so arrays, of course, we have the basic data types. Of course, we already know arrays, which I don't know of any language which, well, technically I believe Lua, and I believe also PHP don't have regular arrays. They have associative arrays, actually, right? They only have one single data type, right? Who is writing Lua?
I have written.
Yeah. So Lua, I believe, only has single type, and actually technically also JavaScript, same thing, right? So it looks like an array, but actually it is associative array. It just so happens, if you think about it, that associative arrays, right, which we know in Python as dictionaries, right, or key map storage like hash maps, right? You can sort of fake them being regular arrays, right? So PHP arrays are associative. Lua tables are associative arrays, right? Again, let me add some links, maybe, in case I'm wrong, right? All right, let's see manual. 5.4, Lua 5.4. Yes, length operator. Where's the table constructors? Table. 8 basic types. You see nil, boolean, nil, again specific type, string, function, user data, thread, and table. Table. Yeah. Table. Yeah, associative arrays. You see? Yep. That is it. 2.1. All right. So what other languages are there which have this weird? So PHP. All right. And again, why is it done? Because it's like, good enough. Associative arrays are, well, sufficient for many things, right? But not most efficient, right? Link, right? Let's see. Array, PHP arrays, an ordered map actually, right? Great. So there's an ordered map. So what does it mean? You also remember what ordered map, what kind of complexity it has. Ordered map. Ordered maps. What complexity? Order. If it's a map, this is key map storage, but ordered. Any idea?
Complexity of lookup?
Yeah.
Wasn't it like
log n? Yeah, it's log n, because why? It's three-type structure. You have to go through, so kind of cool, but also so on, right? Log n, right? Yeah. So, right. Associative arrays. So, right. So, if you don't need the order, which is of course really nice, right? So, we can check, of course, also other ones as well, right? See, right? And of course, again, right? Scala-ups, right? So, associative arrays, right? Which would be, so again, check your data types if you're working with a language, right? What type of dictionary it is, what type of key map, I mean, different names, same thing, right? Just the question is sorted or not sorted, right? Nothing comes for free, basically, right? So, then most languages will have a record data type, right? So basically like structure, right? So it's basically, this already goes under your own derived data types, basically, right? You're gonna make your own data type, basically, right? Case classes, you know, you can make, well, use class-based approach or structures in C++ and C, right? So, because of course tuples, right, record, right? Tuples, you already mentioned this, is the issue with tuples is that they don't really have a context what heck it is, right? You have, you know, what are these values, right? What do they represent, right? Is the third value, it's not very, so not very, right? So not very clear what each element is. Alternative, right? Alternative is to use name tuples, right? From collection report name tuple, I'll show you the idea, right? Person, age, name, weight. Person, age, name, weight. Let's see, name tuple. Oh, let's see what happens actually. Let's take a look at this name tuple. Right, yeah, instance of class. So well, this person age. Oh, I like B42. All right, and weight 100. I hope not. Let's do 90. All right. All right. No. So this kind of like class, right? Right. Go 50 or something, right? All this now you see. So now of course you can look up things like this. So print well this age, right? And well this 0, right? Same thing. 50-50. See? So this is kind of nice. You have not used name tuples. See, it's alternative to using class. So yeah, and of course, yeah, wait. Yeah. So you see, this is yeah. So you get. It's, the only thing is that it's kind of ugly. So kind of ugly. So not very. So you define what fields you have, basically, right? Pretty nice. I recommend using this if you have something. So it's kind of like record, like a structure in C++ languages. Okay. So lists, of course. So again, list types. These are historically linked lists in most languages, with the exception being Python, right? Which are basically really it's just an array of pointers to objects. Really, if you think about it, right? In Python, lists are just a pointer to objects. So union type. We didn't really, you know, in C++, we didn't really explore unions, but it's a very tricky data type, right? Let's look at the example. So what happens with this approach is that union data, right? We have same data, same storage for all three data types, meaning you pick whichever you use, basically, right? So data I10, data F225, right? You will see that actually these refer to the same. You'll be overwriting this here, basically. You'll be overwriting 220 here, basically, right? So very tricky, very tricky, right? And of course pointers, right? So again, pointers of course are what size they are. They usually size of architecture, right? Pointers are variables to, right? Typically pointers are size of the CPU architecture, right? So 4 bytes on 32 bits and 8 bytes on 64 bits system. So some people were really upset when we were going 64 bits because basically all the pointers double in size, right? So that's why 64-bit programs will be bigger than 32-bit programs, basically, because all the pointers double in size. So a program uses a lot of pointers. For example, Python list, right? It obviously uses pointers to all the objects, right? It's based on an array of pointers, right? So you double the size of it, right? So now, so again, the reference is basically, of course, again, we sometimes use interchangeably pointers and references, but in some languages, C++, of course, makes a distinction, right, pointer and reference, because reference is initialized, right, you cannot change it to different object, right, because pointer arithmetic, right, is very powerful, but also notoriously tricky, right? So strong typing, right? So one of the things, of course, is that in 1970s the idea of strong typing, of course, was that we realized what the type of variable we are, right? So strongly typed, it's kind of interesting. The dynamically typed, right? Strongly typed, well, you define the type of variable as a compile type basically, right? So weak typing, right? Easier to write small programs, but weak typing makes it easier to write programs that are more flexible, right? So, but of course, bigger programs. When you do weak typing, it is very, very hard to reason about types, right? Let's say instead of JavaScript, people use TypeScript, for example, right? Python has special data types, right? Type data hints, right? But not so easy. Okay, all right. So what else I want to talk to you today? That is a, this is actually technically, so there's two things actually: static typing, right? That strongly typed, statically typed. This is not correct, right? So technically is strongly typed. Well, so question is actually Python B strong. So let's take a look at it. So this is actually something like kind of like one of those trivia things, right? Well, you say, okay, but I don't have the type because you have things you can do in types, basically, right? So Python, yeah, no, that's baloney. That's baloney. Okay, let's not hallucinate things, right? So you need to follow this again. You can't, right? No. See, strongly typed, right? Okay, yeah. So JavaScript is weakly typed language, right? Okay, right. But I don't want to mess things up. Correction to some data types, right? So deeper look, right? We'll look most of these things here. The other slide. I want to finish this early. Let's see. Yeah. Let's look at a little bit of history, maybe here. Let me see what else is there. We can skip history. You can read yourself. Maybe let me see outline. What else is interesting here? Machine learning, null safety. Yeah, null safety. Structured programming, object-oriented programming, scripting. Right, data types. So yeah, of course, early assembly, of course, do not really have a data type concept. Very just basically, the data types were tied to the hardware. Fortran, remember with Fortran, we had the it sort of arose because IBM machines in the 1950s had floating operations in the hardware, right? So then you could distinguish between actually, then it makes sense to have a floating point type and also integer point type, right? So functional programming, safety, data types, right? So primitive types, we all looked at all this, but string, Unicode, regular expression, right? Right. So support for regular expression, this will be string questions. Let me see if I have anything interesting here. So null safety. Where is my null safety? How about null safety? Oh, there you go. Right. So, as you know, that's the Mr. Hoare or Dr. Hoare, right? Who invented quicksort. He also invented null pointer in mid 60s, right? The billion or trillion dollar mistake. So modern, there's a tendency that not to allow null pointers, basically. You don't have null pointers, or at least you deal with, you have an option type, so you can have, you can have null pointers, but you have to really restrict their usage, basically, right? So, and again, what's the problem with null pointers is that, what is the big problem with null pointers? Well, because they crash the system, right? That's but basically what happens, of course, is you usually have you have object which can do something and do something. You have a chain of things, right? And the first thing is a null pointer, right? It will break things, right? So if you have to keep checking for null safety at each step, right? So it's easy to miss some step, right? And so if you're not forced to do it, if you basically if the programming language does not make you check for null safety, right? you will eventually forget to check something, and your program will crash, basically, right? So it's easy to do it in C and C++ languages. However, even in C++, you can use what you call smart pointers. You can use smart pointers which don't have this problem, right? So even I'll mention this. Okay, here even languages as such as C++ introduce smart pointers. Yeah, because that is a big problem. All right. All right. What else do we want to talk about? Usage, characters. We already talked about strings. Regular expression support, of course, that's already sort of like an extra. Array types, we already talked about those. Associative arrays we talked about. Record types we talked about. Tuples we talked about. List types, right? Again, well, Haskell, we don't really want to talk about Haskell. We talked about closure, right? In closure, right? List is, remember, is a linked list, right? So the access in linked lists is, but if you need to like find the element somewhere, it is what kind of lookup?
Well, it again would be
O to N, because you don't know, you have to go jump through. If you don't have a pointer to that specific area, you have to jump, keep going, right?
usually a bit less.
To me?
Usually.
Yeah, of course, on average will be half, right?
Yeah.
But remember, half of N is still N as far as complexity goes, right? So yeah, it's still bad. But of course, lists, lists have other advantages, right? You can easily add things, right? So, but again, in real life, usually arrays sort of have many more advantages, right? For small, of course, for small lists, no problem. You know, a couple hundred elements, that's fine, right? So, let's see, tells union type, pointers. Okay, so let me have like maybe 5 more minutes for pointers, right? Yeah, so pointers, characteristics. So option type, right? We'll see options in Rust and in Kotlin, right? Very powerful idea. So maybe a little bit, we can see the idea is that you have two things. Either something does not exist, right? Like, it's like a sort of built-in none, right? You have an option, some type, so either you have data type, right? Or none. So this means you can sort of check what's happening, basically, right? It's sort of built-in type checking for your data type. You are sort of like in this construction, you either have an integer, right, or nothing, right? So its alternative would be to have, well, let's say you have possibly values or nothing, right? That's different. Like you have in Python, you can't really do it. You have to have none, right? But here you have special container, right? Some data type and none, right? You avoid null values. Very cool thing. Haskell has maybe, yeah, optional. Very cool thing. That's a type checking. Yeah, yeah. Strict rules for data types. Big taking looser, right? All right, type equivalence. Right, another, oh yeah, right. So, another fundamental concept we haven't talked about today is the type equivalence. What's same? What type of, what data is same, right? So here's an example from C++. 2 pointers. I mean, no, 2 points, sorry, not pointers, points, right? 2 structures, right? So, if your language supports the structural equivalence, it's obvious these are actually the same equivalent types, right? Just 2 integers inside the structure, right? So, means that you can do the same type of things, right? So, so that's advantage, right? Just because you have different names. Or by the way, this is good idea to have it. You say, okay, why should we have 2 different? If these are semantically meaningful, you know, like it's okay to have multiple structures, right? Which do have same underlying structure because you're doing different things. In this case, point 1, point 2, maybe this is not unnecessary, right? But for just have a point, right? But again, idea how to determine. So, right. So more flexible, right? Of course, the potential is that you might mix the types and you potentially lead, it can lead to errors. Okay, what else? Name equivalence, right? Same name regardless of the structure. Let's say, okay, yeah, of course, that's obvious question, right? What else? Yeah, and there is, of course, for data types, some people, well, mathematicians, of course, usually, there is a type theory, right? So dealing with these, how organizing these data types in some sort of hierarchical structure, right? And do it very formally, right?
I have a question.
Yes.
Did Python and JavaScript support the object equivalence?
Meaning you want to compare two objects,
Yeah.
you have to implement them, right?
Okay.
Yeah, you have to implement yourself, but if you want to compare two objects, right, you have to compare them, right?
Yeah.
Yeah, you have to implement equality,
Yeah.
right? In Python for sure. Now with JavaScript, right? It's because first of all, JavaScript originally is prototype language. It was not pure object-oriented language actually. So it's sort of bolted in this object-oriented language, right? It's slightly different structure. So comparing things in there might be a method in JavaScript, right? Good question. Now let's see, because it's been a couple weeks since I've done JavaScript, so I might forget. Remember JavaScript object comparison. I think there was a method, or unless you have done it yourself, right? Well, free code camper, right? So this is like 12 years ago, right? Okay, let's look at this one, MDN, right? Right. So remember, JavaScript is evil, right? Because you have this strict equality and loose equality. Object is okay. Let's take a look. Let's take strict equality, two values, right? Yeah, but yeah, object. Okay, if so, it checks reference basically, right? So that's not quite same. So you have two different objects, right? But they have same contents, right?
Yeah.
So it'll give you false, right? And it depends.
The loose equality checks for the reference pointer, right?
Yeah, it checks the reference pointer. And so if you have two aliases to the same object, yeah, it'll be equal then, right? Just like in Python, right? Yeah, well, Python is Python uses is for that, right? So now, right? So, but of course, Python has JavaScript has lots of exceptions, right? Same value using object is. Functionally, okay, might be good, right? Let's take a look at this one.
And so you have to define it.
Yeah.
So.
Yeah.
So it's like I know I think I've implemented in Java some sort of
Yeah.
comparison.
Yeah.
But,
Yeah, because so you can, so you can implement it, but it's yeah, tricky. Okay, now let's take a look. Let's see. All right. So last thing, type theory is maybe if you are interested in type theory, for theoretical reasons, there's some sources, right? But overall, right, the takeaway from today is that be careful with floats, right? Use name tuples when possible, right? If there's such a thing. Also, optional types, right? Option type, very cool thing in some modern languages, right? Avoids null pointer issue, right? With option types. We'll see this in Kotlin. We'll see this also in Rust as well in follow-up languages. So, on Monday, we start with Prolog. All right, those who are taking AI course will be sort of already ready for it. Those who are not taking AI course will be in for a treat. Yes. A very different type of language. All right, a logical language, if you will. It's fun, but I can tell you already, it's a class. I took it like 20 some years ago. I got the worst grade. I barely passed it on the first run. All right. So. But no, it's okay. It's fun. It's fun. Yeah. Once you get used to it, sort of your brain it's good for like tricking your brain a little bit.